Hey everyone, and welcome to this deep dive. Today we're going to be talking about something that's maybe a little bit technical,
Yeah.
but I promise you it's got some really big real-world implications.
Hmm.
Um, Imagine a company using a personality test to hire somebody for like a super important job.
Right.
Seems fair, right?
Which was fair.
But what if that test actually predicts performance way better for men than it does for women?
Oh, wow.
That's like a recipe for bias, right?
Yeah, definitely.
Even if nobody meant for that to happen.
Yeah, that's a perfect example of what we call differential prediction, where a tool is supposed to be objective but actually leads to these different outcomes for different groups.
Mm.
And the scary part is this can happen even when we're using methods that seem totally fine.
Yeah, so that's where our deep dive comes in today. We're looking at some research by Guinness
A Guinness.
and Pierce. It's pronounced like the beer, by the way.
Okay.
That highlights this like hidden pitfall in a statistical technique that people use all the time called moderated multiple regression, or MMR for short.
Right, MMR. It's super useful when researchers want to understand how the relationship between two things changes depending on a third factor. So, like, does the impact of training on job performance differ for employees with different levels of experience? That's where MMR is really helpful.
Okay, so MMR basically helps us untangle these like complicated relationships. But what is this hidden pitfall you mentioned?
Well, there's a key statistical assumption kind of baked into MMR that often gets overlooked, and it's this idea that the spread of the data points, how much they vary, should be pretty similar across the groups you're comparing. Like, think of it like baking cookies. You want each batch to have a similar consistency, even if you're using different sprinkles.
Oh, that's a good analogy. So wait, if my data is like clumpy in one group but more evenly spread out in another group, that could mess things up.
Exactly. That's exactly what Guinness and Pierce are warning us about. They actually give some visual examples of this in their paper. Figures 1 through 3 show what this looks like in practice. Figure 1 shows the data for both men and women combined. Then they split it. Figure 2 is for men only. Figure 3 is for women only. And you can actually see visually how the spread of the data points is different, which kind of gives you a clue that this assumption might be violated.
Okay, I'm starting to get why this matters.
Right.
But like, how does a weird data spread actually translate into biased results in the real world?
Yeah, that's where things get really interesting. And that's where those real-world consequences come in. So this seemingly technical assumption is directly tied to those issues of differential prediction that we were talking about at the beginning. When this assumption is violated, it can actually warp how the statistical model understands the relationships, potentially leading to conclusions about different groups that are unfair or just plain inaccurate.
So it's not just about getting the numbers right. It's
Yeah.
about what those numbers could lead to.
Precisely. And that's why Guinness and Pierce's work is so important. It's like a call to action for all researchers to pay more attention to this assumption, because violating it can have ripple effects that go way beyond just the data itself.
Wow.
Right. Yeah. And it's not even just about fairness, even though obviously that's super important. This assumption also impacts how accurate our findings are in general.
So like, we could be missing out on some important discoveries
Hmm.
or even drawing the wrong conclusions about the relationship we're looking at.
Exactly.
Yeah.
You got it. Remember those type I and type 2 errors we talk about?
Uh-huh.
Well, violating this assumption can actually make you way more likely to make a type I error,
Oh, really?
which means you might think there's a relationship there when there really isn't.
Oh, wow. So we could be like chasing this phantom effect just because our data isn't behaving how we thought it would.
That's the risk. And then on the other side of that, you could also have like less statistical power,
Right.
which increases your chance of a type 2 error,
Right.
which means you miss a real effect that's actually there.
Okay, so this is some serious stuff. It's like our whole foundation could be shaky if we're not careful about this assumption. But like, how often is this actually happening in research? Is this like a common thing?
That's what's so striking about this. Guinness and Pierce actually looked at a bunch of published studies and found that a surprising number of them had probably violated this assumption.
Oh.
It really highlights how widespread this issue is and why it's so important to talk about it.
Okay, so this isn't just some weird statistical quirk. This is a real problem that's potentially impacting a lot of research out there. So what can we do about it? I imagine it's not always obvious just by looking at the data, right?
Yeah, you're right. There are statistical tests we can use to check this assumption, but they're not perfect.
Okay.
Real-world data is messy, and these tests can be sensitive to those imperfections.
So what's the best way to go about this? Just hope for the best.
Not quite. It's all about combining those formal tests with some good old-fashioned common sense and like carefully looking at the data. It's also super important to think critically about your research design from the very beginning.
So things like choosing the right people for your study and making sure you're measuring what you're actually trying to measure.
Exactly. Being thoughtful about those choices can help minimize the risk of running into this problem in the first place. But what if you've done all that and you still find that this assumption is violated? Well, Guinness and Pierce do offer some potential solutions. One approach is called inverse data transformation.
Okay, that sounds kind of intense. What exactly is that?
Basically, it's a mathematical technique for adjusting the data to try and meet the assumption. However, Guinness and Pierce do point out that it's not perfect. In some cases, it can actually get rid of the effect you're trying to study.
Oh, so it's like
Yeah.
fixing a wobbly table by sawing off a leg.
Hmm.
You might make it level, but you also ruin the table.
Uh-huh. Exactly.
Yeah.
So maybe not the ideal solution.
Yeah. So what else can we do?
Well, the authors suggest that a lot of times the best thing to do is to just use different statistical methods that don't rely on this assumption at all.
So basically changing the recipe altogether to avoid the pitfalls of the original one.
Exactly. And they've even compared different alternative methods to see which ones work best in different situations. They found that some methods are what we call robust, meaning they work well even when this assumption is violated.
That's good to know. So just to sum things up for our listeners, if you're using MMR, be aware of this assumption. Check it carefully. And if it's a problem, consider switching to a different statistical approach altogether.
Exactly. You got it. And I think that brings us to a really important point. This whole discussion highlights how statistics aren't just numbers on a page.
It's not just about crunching data. It's about understanding the assumptions behind the methods we're using
Yes.
and how those assumptions can change our conclusions.
Exactly. And at the end of the day, it's all about using statistics responsibly to make sure our research is as accurate and unbiased as possible.
Because ultimately, those conclusions can have real-world consequences, especially when we're talking about things like hiring decisions or education policies.
Yeah. Couldn't agree more. And that's why this deep dive has been so important. It's a good reminder that even these really technical statistical issues can have a big impact out in the real world.
It's been fascinating.
Sure.
But before we wrap up, I'm actually kind of curious, how do these alternative statistical methods actually work? Are they hard to use?
Well, they can be a bit more complex than standard MMR, but the good news is that statistical software is getting easier and easier to use all the time. There are lots of resources out there to help researchers learn and apply these methods.
That's really good to hear. It sounds like this is an area where researchers need to stay up to date and keep learning as new tools and techniques come out.
Absolutely. And I think that's a great point to end on. Stay curious, keep exploring, and let's keep pushing the boundaries of knowledge together.
Yeah, it really is amazing to think that something as subtle as the spread of the data can have such a big impact on how we understand things.
Yeah, it really does speak to the power of statistics, doesn't it? It's a tool that can help us find the truth, but it's also a tool that we need to be careful with and really understand how it works.
And I think what's been so interesting about this deep dive is realizing that these little details can have real consequences in the world, especially when it comes to things like fairness and equity.
Absolutely. When we're doing research that looks at different groups, especially groups that have been discriminated against in the past, we need to be super careful that our methods aren't accidentally making those inequalities worse.
So it's not just about finding statistically significant results. We need to think about the bigger social impact of our research, too.
Exactly. And I think this whole discussion about the homogeneity of error variance assumption really shows that it makes us ask ourselves, are we using statistics in a way that's fair and accurate, or are we accidentally contributing to bias?
That's a really powerful question.
Your new-
It makes me wonder, what can researchers do to make sure they're using statistics responsibly, especially when they're working with groups that are already vulnerable to discrimination?
Well, I think the first step is awareness. Just knowing about this assumption and what can happen if you violate it is huge. It helps researchers be more critical of their own methods and to really look for any potential sources of bias.
So it's about going beyond just trusting the numbers
Yeah.
and really thinking carefully about the data.
Exactly. And then beyond awareness, it's about being intentional when you're designing your research. Carefully choosing your participants, using the right measures, and thinking about how demographic variables might be playing a role can all help minimize the risk of violating this assumption. And that means reducing the risk of getting biased or misleading results.
It sounds like it's about being both statistically smart and socially aware.
Well said. And I think that's a great takeaway for everyone listening, whether you're a pro researcher or just starting out. Understanding these statistical assumptions and how they can impact the real world is crucial for doing research that's both rigorous and ethical.
Yeah, and remember, this deep dive is just the beginning. If you're interested in learning more, I definitely recommend checking out that article by Guinness and Pierce. They go into a lot more detail about the technical stuff and even give some practical advice for using alternative statistical techniques.
Yeah, it's a great resource for anyone who wants to learn more about moderated multiple regression and how to use it in a responsible way.
On that note, we've come to the end of our deep dive into this fascinating and honestly kind of unsettling topic. But I think it's been super valuable. It's a good reminder that statistics are powerful, but like any powerful tool, they need to be used carefully and with awareness.
Absolutely. Let's all stay curious, keep questioning our assumptions, and keep striving for research that's both statistically sound and socially responsible.
Thanks for joining us on the deep dive. Until next time.